Cool. Let's dive on in then. So this chapter, we're going to basically give a quick rundown on the concept of functions. So what is a function? Some piecewise functions. Students tend to hate those, but they're really not that bad. The concept of domain and range, and then the difference quotient. So the difference quotient, if any of you guys are calc bound, the difference quotient is how we define kind of the most fundamental concept in calculus, called the derivative. So the difference quotient is very important for that. So this right here is a picture of a kind of abstract function, right? But this right here is a function. And so a function is a relation between sets A and B that maps each element of set A to exactly one element in set B. So we normally worry about this on the real numbers, but it can be between any two sets. So this is good because x1 gets mapped to only one thing, x2 gets mapped to only one thing, x3 gets mapped to only one thing, x4 gets mapped to only one thing. But if I were to have this, then that's no good. Or if I were to look at the inverse image of this, then I would be having y2 mapped to both of these guys, which would also not be good. So that might be a little bit abstract. Most of you guys probably remember hearing the phrase, the vertical line rule, right? So the vertical line rule is how we check if something is a function, if we're given a graph. So if I have something that looks like this, any vertical line that I draw goes through only one point. So because it goes through only one point, we're good. This is a valid function, so this works. But if I have something like this, actually, if I have something that looks like this is also good because it's not, the function is not defined here. So if you guys remember, open circle, not defined. There. Filled in circle. Defined there. So this is still good, but if I fill in that hole, then when I do this vertical line test, I go through the same point twice. If I could actually draw a vertical line, that would be a little bit clearer, but does that make sense to people?
I think you're making sense.
Cool. Well, so let's just run through some examples of functions, and hopefully this will. So also just kind of terminological. If you see something like this, we normally say f of x, and then you evaluate f at x, and that's when you just replace. So like if I want to evaluate f of x equals x plus 1 at 3, then I just replace everywhere I see x with 3. And I can even do that with something a little bit abstract, like I can replace it with a plus b, replace it with two other variables. It's still just wherever I see an x, I replace it with a plus b. So that's just called plugging in. So for example, if I want to do f of x equals x squared, I want to evaluate that at f equals, or at -2, then I would do f of -2 is going to be -2 squared is going to be equal to +4, right? F of 0, so that's going to be 0 squared, it's going to be equal to 0. 1 is going to be equal to 1 squared, which is 1. 2 is going to go to 2 squared, that's 4 again, right? What's f of a going to be?
Would it be a squared?
Exactly. A plus b,
AB squared?
not quite, right? It would be a plus b squared.
A
But
plus B
this
squared.
we
Right.
have to FOIL out, right? So this is equal to a plus b times a plus b. So this gives us a squared plus ab plus, plus ab plus b squared. So this is equal to a squared plus 2ab plus b squared. And then f of ab, that's just going to be ab squared, which you can also write as a squared b squared. Does this make sense to people?
I follow.
Cool. So let's look at this one. No, let's just go in order. So f of x equals the square root of x plus 3. Someone want to tell me what I would do for f of -2? Sure, you guys do this by yourselves for a second. Give you a minute to write it out. Someone want to tell me what f of -2 would be?
Would it be a square root -2 plus 3? So would just be the square root of 1?
Exactly. And square root of 1 is?
1, right?
Yeah, just regular old 1. F of 0 is?
The square root of 3?
Yep, 0 plus the square root of 0 plus 3, which is just the square root of 3. Square root, or f of 1 is?
The square.
So I have 2 people talking there?
2.
Yeah. So it's going to be square root of 1 plus 3 is equal to the square root of 4 is equal to 2. F of 2 is going to be square root of 2 plus 3 is equal to the square root of 5. What's the square root of a? Or sorry, what's f of a?
Would it be the square root of a plus 3?
That's exactly what it is. We can't really do anything more with this. That's as good as we're getting it. Something similar goes on for the next one here.
Would it be a plus b plus 3? A square root of a plus b plus 3?
That's exactly it. So I'm just going to clear everything to make some room, but this will be square root of a plus b plus 3. And then somebody finish me off here.
Square root of ab plus 3.
Exactly. So this next one, if f of x is equal to 3, what is f of -2? So what's the
3.
rule? Yeah, it's just 3. So our rule is just wherever we see an x, we replace it with -2. There is no x, so it's just 3. It's just whatever it is there. What about f of 0?
Would it just be 3?
3.
Exactly. It's just 3. 1, 2. What are they?
3.
Okay, what if we do a variable instead of a number? What happens now? What if I
It's
replace still 3? 3 all the way down. Easiest one to consider. You should very much hope that you get a constant function. Very easy to work with. Okay, so consider the piecewise function x minus 1 between when x is less than or equal to -2, 2x from -2 to +2, and then x squared from +2 to infinity. So when x is greater than negative, or when x is greater than +2. So if I want to, what is f of -4 here? So
Would be
first thing,
-6.
yes, it's -5. So the thing that I'm asking is basically, first I have to check which bound is this in. So -4 is less than -2. So that means that this is the one that I use, and I'm good. And then I just plug in -4 minus 1 is -5. What is f of -2?
-3.
Yep, -3, because -2 is less than or equal to -2. You do not use this one. This is strictly greater than -2, so that's no good. And let's go with neon green. F of 0, what's f of 0?
0.
Yes, it's 0, because I look at it and I say, okay, where is this defined? 0 is between -2 and +2, so this is what I'm using. And 2 times 0 is just 0. What's f of 1?
2.
2.
Exactly, because 2 times 1 is 2, and this is the bound that it's in. F of 2. What's f of 2?
4.
Yes, it is 4. And that is, this happens to, they agree at this point, but you are using this one to define it because 2 is greater than or equal to 2. And 2 squared is 4. And
Wouldn't f of 1 be just 1 because x is supposed to be greater than and less than greater than -2 and less than 2?
So x is, but f of x doesn't have to be.
All right.
So our x value is the 1, and then I check, okay, that tells me that this is the bound that I'm using, and I plug it in, and that gives me my f of x value.
All right, thank you.
Cool, no problem. So then this guy, 4 is greater than or equal to 2. Therefore, I plug in into x squared, and that gives me 4 squared is equal to 16. Cool, does this make sense to everybody?
It's making sense to me.
Cool. So I figured, I know you guys all love word problems and you love taxes, so why not shove them together into a single thing? So here we go. This is like an actual old income bracket breakout. So if a person makes $120,000, how much would they expect to pay? So first off, which bounds am I using here? Am I using these bounds? No, x is too big for this, x is too big for this, x is too big for this, x is right in here, right? This is where 120 lies. And now I do, so I use this guy, I use 17,025 plus 0.28 times x minus 8360, or 83,600, and x, we're gonna just plug that in as 120,000. So this is 17,025, $17,000 and $17,025, plus 0.28 times this guy becomes 36,400. Somebody have a calculator? Want to tell me what that is?
Is it two? Oh, I think it's 22,217.
22,000. What do you say it was? 22,000.
Yeah, 22,217.
That sounds right. Wait, no, that sounds a little bit low.
I got 27,217.
Yes, that sounds more like it. And the reason I said that sounds a little bit low is this is a little bit more than a quarter, right? This is just over 0.25, and a quarter of this would be 9,100, right? So 9,100 plus this would be 26. So this sounds right. So that is how much money you would have made, or how much you would have to pay in taxes if you had made $120,000.
I'm sorry, I thought the 7 was a 2.
Okay, no worries. That's how much you would have had to pay in taxes in 2011, assuming like no other, tax deductions, etc. So then, how much would a person expect to pay if they made 80,000? So if they made 80,000, then they would be using this formula, and they would have 4750. 4750 plus 0.25 times x minus 34,500. But this right here, x is 80,000. So that would be, this would give us 45,500 times 1/4 plus 4750. And anyone want to tell me what that is?
I got 16,125.
16,125, you said?
Yes, is that wrong?
No, that looks like it's right about what I was about to get, but I was doing this in my head, so I'm less confident about that. So yes, that sounds about right. So 16,125. Yes, that is exactly what I would have gotten. Thank you. So this is how much you would have paid if you got 80,000. Also, in case you guys didn't know before, this is how tax brackets work. So basically, this number right here is what you would pay if you paid the entirety, like you filled up that 35,000. If this is 4,750, is what you would get if you plugged in that 34,500 to this equation. And then this is basically saying, okay, the rest of the money that you earn, this is how much you're paying in taxes. 0.25, so you're paying 25% in taxes for the remainder until you actually hit the next tax bracket. And this is how much you would pay if you had done 83,600, and then this is you're paying 28% on what's ever left over after that until again you hit the next tax bracket. So that's also before you do any, like the X would be however much you make after you do any deductions that you have. So yeah, so find f of 1 and f of 3 for f of x is equal to that guy. So what would they be?
For f of 1, it would be 3 times 1 squared plus 2 times 1 plus 1.
Yep. And that is just going to be equal to 3 plus 2 plus 1 is equal to 6. Right? What's f of 2 going to be? Or sorry, f of 3.
So 3 times 3 squared plus 2 times 3 plus 1. So that would be 27 plus 6 plus... Would it be 34?
Yep, exactly. Thank you. So f of x is equal to 1 over x plus 2. So what do we have here if we just plug in -1? Yeah, we end up getting 1. So we get f of -1 is equal to 1 over -1 plus 2 is equal to 1 over 1, which is of course just 1. About f of 1/2, what's that?
Would it be 1 plus... Yeah, what you just wrote.
Yeah, but then we can actually do something else to this guy. So if we divide by a fraction, it's the same thing as flipping it over, right? So this is how it simplifies. 2/5. What's f of 2 going to be?
F of
1.
2 would... Oh, never mind.
Hmm?
I thought somebody else was going to answer.
Yeah, I think I went from 2 people trying
1.
to answer to no people. Someone want to tell me what is?
1/4.
Yes, 1/4. Thank you. So we have 1 over 2 plus 2 is equal to 1 over 4. Cool. What about g of h is equal to square root of h minus 3? So if we do g of 3 here, what is that?
Would it be 3 minus 3 squared?
Square root, right? Square
Oh,
root
square
of 3
root.
minus 3.
Right.
Ends up being the same for this one, right? But it's important to keep straight. So this would end up being 0, square root of 0, which is 0. G of 7, what's g of 7 going to be?
Square 2.
Not square root of 2.
No, just 2. Just 2.
Yes, yeah, you shove the 2 steps together into the same thing, right? So we get square root of 4 is equal to 2. 84, g of 84 is going to be,
Square root of 81.
yeah. So, and someone already said, I think, square root of 81 is 9. Cool. So if we have f of x there, yeah, so I'll do this one and this one with you guys, and then I think you guys can handle the other two. So what is f of a plus 3 going to be? I think someone just said something, but I couldn't understand what.
Oh, sorry. I was trying to think it out. I think it might be, would it be 8x plus 5 plus 3? No.
Well, so everywhere we see, so we won't have x in there anymore, right? Because we have a now instead of it. But everywhere we see an x, we replace it with a plus 3, right? So if 8 times x becomes 8 times a plus 3. And then we still have that plus 5. So this right here becomes 8. We have to distribute that. So this becomes 8 plus 24 plus 5 is equal to 8a plus 29. That makes sense to people?
I think I get it now.
Cool. So f of a plus h, that's going to be something similar. We're going to have 8 times a plus h plus 5. So that becomes 8a plus 8h plus 5. Cool. So, and you guys can do the other two. This one is kind of similar to what we did earlier with the f of 3, like everything was 3. You're going to get the same basic rundown for this guy. For this one, let's just run through all of them. So what is f of 10a going to be? Well, everywhere I see an x, I'm going to replace it with 10a. So this becomes,
Oh, sorry, I was thinking, would it be 10a times x squared plus 3x minus 1?
well, we don't just multiply it in, right? When we're plugging into the function, just everywhere we see a 10a, or sorry, everywhere we see an x, we replace it with a 10a. So for this guy right here, we have x squared, so that's going to become 10a all squared. And then plus 3x, that's going to be plus 3 times 10a. And then minus 1 is just minus 1. So this right here, if I do this out, it becomes 100a squared plus 30a minus 1. And that's how that ends up. Does that make sense to people?
Okay, so instead of replacing x with 10a, you're just replacing, every time you see an x in the equation, you replace it with 10a, right?
Yeah.
Okay.
So that's why x squared becomes 10a squared and 3x becomes 3 times 10a. Does that make sense?
Maybe, yeah.
Okay. hopefully the next example or two will make it feel a bit more comfortable. So if we do f of negative a, what's that going to be?
Negative a squared plus 3 negative a minus 1.
Yeah. Depending on, it's a bit ambiguous when you're like speaking it. So you can either mean that as negative a squared or like this, because these are not the same thing, right? This right here is equal to positive a squared when you, because the negative gets multiplied by a negative and becomes positive. Just like negative 2 squared becomes 4. And then we have, so this becomes minus 3a minus 1. Right? Does that make sense to people?
I think it makes sense.
Okay, cool. So if we do f of a plus h, what does that become? Well, we get a plus h squared plus 3 times a plus h minus 1, right?
Right.
So, does that make sense to people?
Okay, so then wouldn't it equal a plus h times a plus h plus 3a plus 3h minus 1?
Yeah. And the only thing is I'm just going to distribute that a plus h to kind of simplify it all out. So we get this plus h squared plus 3a plus 3h minus 1. But that's what you said before was correct. And let's just wrap everything up with this one. That'll look very similar to this, but we won't have the variable of the h anymore. And the a's will be replaced with x's. So if we do f of x plus 1, that's going to be equal to x plus 1 squared plus 3 times x plus 1 minus 1. So this is going to be x squared plus 2x plus 1 plus 3x plus 3 minus 1. So this cancels with this, and we get x squared plus 5x plus 3. Does that make sense to people?
I think it makes sense.
Cool. So like I said earlier, this one is ends up being very similar to the, I guess like the third problem we did. But yeah, I'll just do the first one for this and leave you guys with the rest. So if I do f of 2u plus v, what's that going to be?
2u plus v plus 1 over 2u plus v plus 2.
Exactly. And I'll just do this one for you guys. That would just be 1 over u plus over 1 over u plus 2. So the difference quotient, like I said, I mentioned this at the start of the class. If you guys are going on to take calculus, this is how we define the derivative. And like the derivative is kind of at a given moment how fast something is changing. So this basically looks at how around the point A, how quickly is this changing. So this looks at, I were to draw a graph. If this is a plus h, you kind of have that slope, like the slope of the line that connects these 2 points. And as you shrink that, you get what's called the derivative. But this right here is called the difference quotient. and we're gonna plug it in and see how much we can simplify things. So using this definition, find the difference quotient for this guy. So this would be everywhere I see an x, I replace it with an a plus h. So what does that become?
So you said a plus h would equal what?
Well, so everywhere we see an x in this, we replace it with a plus h.
Okay,
we're
so
trying to find what the difference quotient simplifies to.
would it be a plus h squared plus a plus h plus 2?
Yeah, nice.
And
And then we
then-
subtract f of a. So what's f of a?
Okay, f of a, then it would be a plus h, or
Well, we don't have an h anymore, right? We're just doing f of a. So everywhere we see an x, we replace it with an a.
okay, so a squared plus a plus 2.
Exactly. So we have to distribute that negative. And I'm going to just distribute this too. But this is all over h still, so remember that. So we've got, this is a squared plus 2ah plus h squared plus a plus h plus 2. And then if we distribute this negative, this becomes minus a squared minus a minus 2. Still all over h. So this minus 2 cancels with this plus 2. This minus a squared cancels with this positive a squared. Minus a cancels with this plus a, and we're left with 2ah plus h squared plus h all over h, right? And now we can simplify this a little bit. We can cancel this h with this, which becomes 1. One of these h's and this h right here. So this becomes 2a plus h plus 1. Does that make sense to people?
I think so.
Yeah. So in case people didn't get what I did there, this right here is equal to 2a plus h plus 1 times h. And because it's over h, we just kind of canceled this. That's equivalent to how I did this right here. They mean the same thing. Does that make sense to people?
I think you're making sense.
Yeah, I think it makes sense.
Cool. We've got another couple examples, and then we can actually I'll do, let's do this one. So reminder, difference quotient is f of a plus h minus f of a all over h. So if I want to do the difference quotient for g here, it's going to be the same thing now, just these f's become g's. And what am I going to get here? What's this going to look like?
Okay, so you're just replacing the x with 1 over x.
Well, everywhere I see, so I have g of x is equal to 1 over x, but everywhere I see it an x, I'm going to replace it with a plus h for the first one, and then just a for the second one, right?
Okay.
So what happens when I replace a plus h, x with a plus h?
So you would just have 1 over a plus h.
Yeah, we get 1 over a plus h minus g of a is?
G of a would be 1 over a.
Yep. And this is all over h. So I want to be able to combine these. So how am I going to do that? I'm going to make sure that they have the same bottom. I'm going to do that. I'm going to multiply this by a over a. and this by a plus h over a plus h. And then I'm also just going to move the 1 over h up front. So then this becomes a divided by a plus h times a minus a plus h divided by a times a plus h. So I can combine these guys and I get a minus a plus h all over a times a plus h. And if I distribute this negative, it becomes plus minus minus. This cancels with this, and I'm left with negative h. And sorry, I forgot there's still the 1 over h on the outside here. Divided by a times a plus h times 1 over h. So this cancels with this, and I'm just left with negative 1 divided by a times a plus h. Does that make sense to people?
Okay, I think I get it now.
Okay. Yeah. So jump forward and let's do some domain and range problems. So the domain of a function are the values that you can map from. So they're the x values that you can plug in. So there's like for a square root, you can plug in any positive or any non-negative number. So you can plug in 0 or a positive number, and then like it's valid. Like you can plug those in and get something out. In this class, we will work with imaginary numbers later on, but you don't have to worry about it in terms of the domain and range of square roots and things like that. Like for right now, imaginary numbers don't exist. Another thing that comes up is so like you can't divide by 0. So that's something you have to worry about for the domain and range. Also, when we get to trig functions eventually, we'll have to worry about that, but we don't have to worry about trig functions quite yet. The range is the y values that you can hit. So if I look at the absolute value of x, you're only going to get positive numbers, right? Same thing, or non-negative numbers. You can also get 0, right? The absolute value of 0 is 0. Or if I look at x squared plus 1, then all of the numbers are going to be greater than or equal to 1, right? So those are the range. Those are the values that we can hit. We're usually going to use this as interval notation. So let's just kind of dive into this and see. So the interval notation, usually looks something like c to infinity. You guys have probably seen something like that, but we'll get some concrete examples going here in a minute. So what's the domain of this? Well, this top, that can take anything, right? Like I can plug any x value into x squared minus 4, if that works. Bottom, I can plug in any x value and get out a valid answer, right? But I need to remember that the bottom cannot be equal to 0. So I need x plus 3 is not equal to 0. So that means x is not equal to negative 3, right? So how will I write this as interval notation? Well, I'll do negative infinity to negative 3, and then I'll do union through negative, sorry, these are both negative, negative 3 to infinity. And so this right here means not included. If I had done negative 3 to infinity, this means included. Does that make sense to people?
Okay.
So square brackets are included, parentheses not included. But this one, what's the domain for this guy? I should do the range for this too. No, I won't bother with the range for that one. It's kind of more difficult than I want to deal with. So, any ideas on how to factor this? It already comes with a hint.
Okay, so I think a good idea would to be group x to the third minus x and 2x squared and -2.
Yeah.
So you can factor each over.
So this becomes this, right?
Yes.
So this is equal to x plus 2 times x squared minus 1. And then we can factor x squared minus 1 also, right? So if you guys remember difference of perfect squares or difference of two squares, what does this become?
Would it be x plus 1 times x minus 1?
Exactly. So we have to have any of these equal to 0. So that means that x is not equal to -2, because that would make this guy equal to 0. So it's going to be like the opposite of the sign that you have from this. And this would give us x is not equal to -1, and this would give us x is not equal to +1. So if we want to write this in as an interval, we would get, we would get -infinity to -2, union -2 to -1, union -1 to infinity. Sorry, -1 to 1. Union.
And then like 1 to infinity.
Exactly. Does that make sense to people?
I think it does.
Cool. So this guy right here, we have this top, that's always going to be defined, right? But this bottom, we have to make sure that we're not dividing by 0. The bottom's always defined too, so that's not going to be an issue, but we have to make sure that we're not dividing by 0. So what happens if we divide by 0? So that tells us that x squared plus 4 cannot be equal to 0, right? So that tells me x squared cannot be equal to -4. So this is good, right? That doesn't actually matter, like it's all good. X squared is never going to be equal to -4, so that doesn't give us any other restrictions. So there's a few ways you can write this. You can write it as -infinity to +infinity. You can write it as all real numbers. And if you want, you can do it as what's called blackboard bold R. So it's something that looks like that. Does that make sense to people? So, and
Okay. Pardon me?
yeah, sorry, what were we saying?
Oh, I was just want to make sure, since because of the x, because it's squared, the number will always be positive no matter what you put in. So that's why it's all real numbers.
Exactly. Because this right here is always positive. Like it's never going to be equal to 0. So basically it's all real numbers because you can plug in any number and it will give you out a valid answer. And the reason is because the top can take in any number and give you a valid answer. The bottom can do that. And the bottom is never going to be equal to 0, so you never divide by 0. Because divide by 0 gives us something that's undefined, right?
Okay, thank you.
This one, let's do domain and range. For these next two, let's do domain and range. So what is going to be the domain for this? what was our rule for square roots?
Like, I think it was don't have the number equal to 0.
Well, that's when we divide by, like, we can't have the bottom equal to 0. Square roots is something related to 0, but it's not that it can't be equal to 0. Like square root of 0 is fine, right? Square root of 0 is just 0. But if I give you square root of -1, that's not good, right? So
Right. Can't be
Greater
a
than or
negative
equal
number.
to 0.
yeah, so we need that the inside has to be greater than or equal to 0. So we have x plus 3 is greater than or equal to 0. So that means x is greater than or equal to -3. So how do we write that? We write that as -3 with a square bracket because it's or equal to infinity. And infinity always has a parentheses because we can't plug in infinity. Cool. So this is the domain, right? What's the range for this going to be? What's the range for square root? So let's actually just kind of show what this looks like as a function. So we've got this starting off at -3 and got that nice little square root kind of arc there. So what y values can I hit?
Everything greater than 0.
Yes, I can hit 0 and I can hit anything bigger. So that is my answer. Does that make sense? Okay. Sorry, I am over time. I want to point out that this guy right here is always greater than or equal to 0. So this domain will be -infinity to infinity. And the range is going to be, the worst you can have is 7, square root of 7. If that's the lowest x squared plus 7 will ever be. So the range will be square root of 7 to infinity. Sorry, I lost track of time there. Have a good weekend. Hope your first week of classes was good. I'll stick around and answer any questions if people need it.
Thank you for your help. Have a good day.
Thank you. Have a great day.
Thank
You too.
you.
Oh, I hate the